Hi, today we're going to talk about the science inquiry process. So as you know, the title of this unit is the inquiry unit, right? So what is science inquiry? And that's what we're going to explore today. We've been talking a lot about variables, independent variables, dependent variables, constants, right? And variables are a really important part of the inquiry process. So we're going to have several units that we cover this year. We're going to talk about weather. We're going to have a unit on genetics. We'll have a unit on landforms and climate change. There are a lot of different topics that we're going to cover this year. But we're starting with science inquiry because science inquiry is all about the process that scientists follow to answer their own research questions, right? And the reason we know anything about climate or weather or genetics is because of the scientific process that scientists follow, right? It's because of the experiments that scientists do and the evidence that they gather to answer their own research questions. And so that's what we're going to be focusing on. And no matter what we're studying this year, we're always going to be looking at it through a science inquiry lens. We're always going to be looking at it through the lens of how did scientists figure this out? Okay? All right, so the essential question for this set of notes is, what is science inquiry? And what steps do scientists follow when they conduct an inquiry investigation? So we're going to learn what science inquiry is, and then we're also going to talk about the steps that scientists follow when they do an experiment. Okay, so what is science inquiry? An inquiry is an investigation or experiment that tests and answers a scientific question using evidence from data. Okay? Now, remember that a fair test has only one IV, only one independent variable, okay? So each investigation can answer only one question. So for example, if you were looking at how the amount of water that you give a plant affects the plant's height, you might have one plant that gets very little water or no water and another plant that gets a lot of water, right? And then after a week, you might see how tall they are and compare. In this case, when you go to answer the question at the end, the only question that you can answer based on this experiment is how the amount of water affects the plant. You can't make any sort of conclusion about how the amount of sun affects the plant. You can't draw a conclusion about how the amount of fertilizer affects the plant or how the soil affects the plant. The only question that you can answer from this experiment is how the amount of water affects the plant. And that's because we only ever want to have one independent variable, only one thing that you purposely change for each of your groups to see if it makes a difference. So because there's only one independent variable in each experiment, you can only answer one specific question with each experiment. Okay, so the inquiry process is the process that scientists follow to conduct their investigations. It is often referred to as the scientific method. Okay, so sometimes we call it the inquiry process, sometimes we call it the scientific method. They are one and the same thing. The scientific method, the inquiry process, is really just a step-by-step process that scientists follow to answer their research questions using evidence from data. Okay? All right. In your inquiry unit INB, on the right-hand side of slide 16, you will see a diagram that looks just like this. This diagram is a flow chart that shows you the process that scientists follow when they're doing their experiments. This right here is the scientific method or the inquiry process. The first thing that scientists will do when they're doing an experiment or when they're going to start an investigation is they will make observations, right? So step one is make observations. They will notice things. They will write down the things they hear, the things they see, the things they notice. And then based on those observations, they will come up with a testable question. Once they know what their question is, that's when they go and do some background research to see what they can figure out about the subject, right? So they do a little bit of background research, find out what's already known about the subject, and then based on that background research, they will write a hypothesis. They will make a prediction about what they think the results of their experiment are going to be, Okay, they try to answer the testable question before they ever do the experiment by writing a prediction, by writing a hypothesis. So this is step 3, background research and write a hypothesis. Once the scientist has written their hypothesis, then they're going to develop a procedure for how they're going to test their prediction. Okay, so this is step 4, writing a, sorry, let me get my pen. There we go. This is step 4, writing a procedure or a step-by-step plan for how they're going to test their prediction, how they're going to try to answer the question. And this is where variables comes in, right? This is where the scientist wants to think about what kinds of things they need to keep constant for each of their groups, what they're going to measure at the end of their experiment, so their dependent variable, what they are going to purposely change for each group in their experiment, so their independent variable. All of these variables considerations are part of writing the procedures, okay? Once the scientist has written their procedure, then they're going to actually do the experiment and collect some data. So this would be step 5. And then once they have their data, they're going to graph it so that they have a visual for their data. And then they will use that graph to do an analysis, to look at that data and try to draw some conclusions from it. So this would be step 6. Once the scientist has graphed their data and analyzed it, processed it, then they're going to write a conclusion. Okay, so they're going to go back and try to answer the original testable question, and they're going to say whether or not the data supports their hypothesis or proves their hypothesis wrong. Okay, so sometimes the hypothesis will be supported, right? Sometimes the data will support the hypothesis. It will appear as if the scientist's prediction was right, okay? And then sometimes the data will prove the hypothesis wrong, right? Sometimes the researcher or the scientist will have to say, well, you know, based on the data, actually the evidence makes it seem like my prediction is probably wrong. My hypothesis was refuted. It's okay if your hypothesis is refuted. We learn something from that. So it doesn't matter whether your hypothesis is supported or refuted. You always learn something from testing your hypothesis and collecting data, even if your hypothesis was wrong, okay? So even if the hypothesis is wrong, you're always going to share out your results with the community. So this is step 8, okay? Whether your hypothesis was supported or refuted, you always want to share your results with the scientific community, okay? If your hypothesis was refuted, right, if your prediction did seem to be wrong based on the evidence, based on the data collected, that's when you're going to kind of think again, right? You're going to go back, think again, and then you'll notice a little arrow over here. Come up with another hypothesis. Come up with another prediction, right? If your prediction was wrong, then let's make another prediction, write a new set of procedures, and test that prediction. Okay, so you'll notice that if the hypothesis was refuted, we kind of repeat the cycle. All right. Okay, so at this point, I'm going to have you stop the video. This is the end of the video, so you don't even have to stop it if you don't want. But you're going to stop this video. You're at the end of the video, and now I want you to write a summary for this page of Cornell Notes. A summary should be anywhere from 4 to 6 sentences. Okay. So you'll notice on slide 16 in your inquiry unit INB, on the left-hand side of slide 16 at the very bottom, there's a little summary section, and I want you to write a summary of what this set of notes was about. Your summary should answer the essential question for these notes. All right, thank you.